in talking about quadrilaterals, which is the next polygon, triangle has 3 sides, a quadrilateral has 4 sides. So this is the general name for a 4-sided polygon. Then the quadrilateral has different shapes, and those shapes have different properties. So we say a trapezoid has exactly 1 pair of opposite sides parallel. A parallelogram has both pairs of opposite sides parallel. A rhombus is a parallelogram that has 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And a square is a parallelogram with 4 right angles and 4 congruent sides. And then if we put the word regular in front of polygon, that means that we have equal sides and we have equal angles. That means that it is equilateral and equiangular. Now, there are a couple of things that we can do to help students with learning the names for the quadrilaterals and the definitions or the properties that the quadrilateral has. One is to create a flip chart. And you know that a flip chart has, it's like this. And so you would have the word square. And then when you open it up, you would have the definition of a square. And then you would have your next sheet would come down just a little bit less, and it maybe would have parallelogram. And then when you open it up, you have the definition for a parallelogram. So you know what a flip chart is. So that's what I recommend that you do with students as they are learning about quadrilaterals. And you might want to do that for yourself so that you remember the properties of all the parallelograms. Now, what I like to do in terms of creating an idea of how quadrilaterals are all related to each other, I like to create a family tree. Where quadrilateral is the family name for all 4-sided figures or all 4-sided polygons. One that we rarely ever talk about, I guess, is the weirdo of the family, is the trapezium. I've got that spelled wrong. Trapezium. What makes a trapezium is that it has no sides congruent and it has no angles congruent. And it has no parallel sides. So it might look something like this. So it has no angles congruent, and it has no parallel sides, and it has no sides congruent. Okay, another child of the quadrilateral is the trapezoid. Now, the trapezoid has exactly one pair of sides parallel. So we typically see a parallelogram drawn like this. This shows the two sides that are parallel. But we can have a parallelogram that has right angles. These two sides are parallel. So they don't all have to be made like this, which is how we typically see them. Another member of the quadrilateral family is a kite. And what makes a kite special is that it has each pair of adjacent sides congruent. So these two would be congruent, and then these two would be congruent. So no sides are parallel, but it does have these properties of having adjacent sides. Two pair of adjacent sides congruent. Now these trapezium is rarely mentioned. The trapezoid and the kite we hit on fairly well. The kite maybe not as much as the trapezoid. And then we get to the family of parallelograms. And what makes a parallelogram is that it has both pair of opposite sides congruent and parallel. It has opposite angles congruent. Its diagonals bisect each other. And typically we draw a parallelogram that looks like this. That's our typical parallelogram, where we have opposite sides parallel, opposite sides congruent. We have opposite angles congruent. I'll draw it a little bit bigger down here so I can show you, well, not a very good parallelogram. Its diagonals bisect each other, meaning that these two segments are congruent and these two segments are congruent. They're not all four congruent to each other. These two are congruent and these two are congruent. That's the properties of a parallelogram. Well, the parallelogram had some children. Now we're still looking at quadrilaterals. These are grandchildren of the quadrilateral, and that would be a rhombus. And normally we draw a rhombus like this. Some elementary textbooks call this a diamond. And, you know, a diamond to me is a stone. I like to wear diamonds. The shape is a rhombus. A rhombus is a quadrilateral. It has all properties of the parallelogram. And it has one of its own. And that is, it has four equal sides. Or we could say congruent. Now something else that the rhombus has that a typical parallelogram does not have to have, and that is its diagonals are perpendicular to each other. So we could say that they're perpendicular bisectors of each other, meaning these two segments are congruent and these two segments are congruent, but there's a right angle here. So we like this a lot because this allows us to look at right triangles, and we can prove these two triangles congruent by the side angle side correspondence. Now another child of the parallelogram is a rectangle. So a rectangle has all properties of a parallelogram. And then it has some of its own. It has four right angles. It has congruent diagonals. So when I look at the typical rectangle, we have our four right angles, and then the diagonals are congruent to each other. That means that when they bisect, which is a property of the parallelogram, these four segments are all congruent. So that allows me to prove that these two triangles are congruent because these are vertical angles, and vertical angles are congruent to each other. So I have a side angle side correspondence showing these two angles, these two triangles, to be congruent. The same for these two, side angle side, because of vertical angles being congruent. Alright, last for the parallelogram, we have the square. So the square has all properties of the parallelogram. It has all properties of the rectangle, and it has all properties of the rhombus. So often we have statements that are true or false, saying a square is a rectangle, and that would be true because a square has all properties of a rectangle. We could say a square is a rhombus, which would be true because a square has all the properties of a rhombus. And we could say a square is a parallelogram, and that would be true because it has all properties of a parallelogram. A square is a quadrilateral because it has all properties of a four-sided polygon. But then if we go the other way and say a rhombus is a square, then that's false because a rhombus does not have to have four right angles, which is a property of the rectangle. I can't say a rectangle is a square because a rectangle doesn't have to have four congruent sides. So in looking at what is and what isn't, notice that these are all squares. Squares do not always have to be turned like this. These are squares as well. These are all parallelograms. So this is what a typically the way we draw a parallelogram, but A rhombus is a parallelogram, a rectangle is a parallelogram, a square is a parallelogram, and then this is how we typically see our parallelogram. Now in this, which of these are trapezoids? So it doesn't work like it did before. This is a trapezoid, but this is not, because you can only have one pair of opposite sides parallel. This has two pairs parallel. So this is a trapezoid, this is not, and this is a trapezoid. Examples of rectangles. This is a rectangle. It has 4 right angles, has all the properties of a parallelogram. It's examples of rhombi. The plural of rhombus is rhombi. This is typically how we see it drawn, but it could be drawn like this. The square is a rhombus, and then these are also examples of rhombi. Now, if we have just the word quadrilateral, quadrilateral is a 4-sided polygon. So these are all a part of the quadrilateral family. These are examples of kites. Sometimes we don't think of this reflex angle creating a kite, but a kite has adjacent sides congruent, and it has 2 pairs of adjacent sides congruent. So this would be a kite. This is how we typically think of a kite and how we typically draw it, but it doesn't have to be just this way. It could be like the other examples. If you would like, you could give students a family tree titled Quadrilateral and have them fill in the blanks on the relationship. This would be just maybe a parallelogram. And then there are many investigations where you can give students examples and have them measure the angles and then determine what kind of quadrilateral that you have. I'm not going to have you do this investigation, but in your class, if you're teaching this, it's nice to have the students working in groups on an activity where they are determining what kind of shape it is based on its properties.